Graphing quadratics in vertex form. In a previous video, we talked about vertex form, which was y equals a times x minus h quantity squared plus k, where the vertex is at h comma k. That was vertex form. We're going to now use vertex form to actually graph parabolas. And when you're doing this, the way that Alex has you graph these is very specific, so I'm going to be tailoring this video to the way that Alex likes their parabolas graphed. The first step, we need to plot the vertex and the axis of symmetry. So step one, plot the vertex and axis of symmetry. I'm going to abbreviate sim as SYM, the axis of symmetry. Our h value, remember that the h value is always the opposite of what you see. So h is -4, k is -6. That means that our vertex is at -4, -6. That is my vertex. My axis of symmetry is going to be a vertical line that goes directly through it. The equation of this line is x equals whatever the x value of the x value of the vertex is. So this is x equals -4. That's the equation of that line. The next step, with Alex requires a very specific thing. I'm going to draw a really generic parabola right here just to talk about it. Alex requires that you draw the vertex and that you draw 2 points on either side of the vertex. So we need 5 points total before Alex can graph this. We need 2 over here, 2 over here. The axis of symmetry is great because that means we only actually need to find 2 points on one side, and then we can use the axis of symmetry to plot those other points. So step 2 is you are plotting 2 points to either the left or the right of the vertex. I'm just going to choose right. That's what I'm going to choose. It's right or left. Plot 2 points to the left. Not left. I'm going to do right. It doesn't matter, again, I'm doing right. To the right of the axis of symmetry, I'm going to abbreviate as AOS. So plot 2 points to the right of the axis of symmetry. The x value that we're using for our vertex, the x value of our vertex is -4. So if you're looking at x values that are to the right of that, you can just choose the immediate 2 to the right, -3 and -2. So we'll do x equals -3. We'll do x equals -2. We'll be plugging these values into our equation to find y values, and that will give us coordinate points. So these coordinate points are going to end up being -3 comma some y value and -2 comma some y value. For -3, plugging -3 into this equation, 2 times -3 plus 4 squared minus 6. That's going to be 2 times 1 squared minus 6. 2 minus 6 is -4. Okay, so this is the point, -3, -4. Okay, you plugged -3 in for x, and it popped out a y value, -4. So we can plot the point -3, -4, and use the axis of symmetry to plot its partner point. And maybe I'll do that in the next step. I'll write that in the next step. So we'll just plot one for now. Come over here. Here, we're plugging in -2 to the function 2 times x plus 4 quantity squared minus 6. So y equals 2 times -2 plus 4 quantity squared minus 6. Okay. -2 plus 4, that's going to be 2 squared minus 6. Let's see. 8 minus 6 is 2. So this is the point -2, comma 2. That's right up here. So I plugged -2 in to this function, and then it gave me a y value, which was 2. These guys right here are the coordinate points. Okay. I plotted the coordinate point -3, -4, plotted the coordinate point -2, 2. Again, I want to mention how I determined to use -3 and -2. I looked at where my vertex was, right? It's on the x value -4, and I just chose the immediate 2 numbers to the right. Those are the values I chose, and I plugged them into the original equation to get the y value. Step 3, use the axis of symmetry to plot 2 additional points on the right. Use axis of symmetry. Symmetry. To the left of the axis of symmetry. So for this point right here, there's a distance of 1. So in the other direction, if I go 1 unit to the left, I can plot another point. Up here, this guy is 2 units away. So I'll just go 2 units away on the other side and plot another point. And now we have enough points to make do. So come on, Notability, you can do it. You know that it's a parabola. I know I get super nitpicky with the way my graphs look, but that's who I am. All right, there it is. That is the graph of y equals 2 times x plus 4 quantity squared minus 6. It's really not that bad. I promise. Let's do it again. And man, I changed this in the future and I didn't change it here. Erase this. Make this into y equals -3 times x minus 2 quantity squared plus 7. Change it on your notes. We're doing that instead. All right. It's the same steps though. All right. We're going to find our h value, our k value, give us our vertex, plot the vertex. Our h value is +2. Our k value is 7. So our vertex is at 2, 7. Over 2, up 7. There's my vertex. With it, I can plot my axis of symmetry. The equation of this line is going to be x equals 2. It's always x equals the x value of the vertex. So x equals h. Then I'm looking at the 2 x values that are immediately to the right. So I'm looking at 3 and 4, and I'm going to plug those into my original function to get 2 points. So I have x equals 3. If I plug in x equals 3 to this function, I get y equals negative 3 times 3 minus 2 squared plus 7. Okay. I'm going to highlight. I plugged in 3. This is negative 3 times 1 squared plus 7. Negative 3 plus 7 is 4. That's the y value. So the coordinate point is the point 3. I'll write it like this. The x comma y coordinate point is 3, 4. The 4 from the y value, the 3 from the x value. So let's see. 3, 4. Using symmetry to plot the other point. Right, so this is 1 unit away. On the other side, 1 unit away is another point. I'm now going to use the x value 4 and use that to plot another point. So y equals negative 3 times 4 minus 2 quantity squared plus 7. Negative 3 times 2 squared plus 7. That'll be negative 12 plus 7, which is negative 5. So the point that we're going to plot is the point 4, comma, negative 5. Using the axis of symmetry, we can plot another point. So this is 2 units away. I can plot another point here. Should have used black. Another 2 units away. And that's enough for us to draw in our parabola. Come on. I don't know why it wants to give me a hard time when I'm doing these videos. I feel like anytime I'm not doing a video, it's perfect. And the second I start doing a video, it just won't draw parabolas for me. Close enough. There it goes. So again, plot the vertex, plug in 2 x values, get 2 more points, use the axis of symmetry to get an additional 2 points. Now you have 5 points, and that's enough to draw the graph of a parabola. Let's look at another problem. Find the following and graph y equals negative 2 times x plus 2 quantity squared plus 8. And there's quite a few questions for us to answer. So let's start. Opens up or down? Well, the value out front is a negative 2. If a is negative, that means that the graph opens down. The vertex. Our h value is negative 2. Our k value is 8. So our vertex is at negative 2, 8. There's my vertex there. The axis of symmetry goes straight through my vertex vertically. It'll always be a vertical line. The equation is x equals the x value of the vertex, which is negative 2. So the axis of symmetry is x equals negative 2. It really is just, right? This is the x coordinate. The axis of symmetry is x equals negative 2. The x-intercepts. The x-intercepts. There are 3 possibilities when it comes to x-intercepts and parabolas. So if I just kind of draw Three examples for you of what can happen here. We could have a graph that, I know our graph opens down, but, or yeah, I know our graph opens down, but it doesn't matter. We could have get back. We could have two x-intercepts if the graph opens in such a way where I don't know why that stopped sharing. You need to reboot at this device. Why don't we not do that? Give me a sec. Let's see. There we go. Hopefully it's not going to crash on me. So you could have it so that you have two x-intercepts. You could have it so that the graph the parabola never hits the x-axis. For instance, if it were opening up like this and it never hit. Or you could have one x-intercept. So imagine that this parabola, was just sitting with its vertex on the x-axis, in which case it would have one x-intercept. So those are our options. Either this thing's going to have two, it's going to have none, or it'll have one. Now, because it opens down and our vertex is above the x-axis, it is going to have two, just by the shape it's going to make. It will have two. The way that we find x-intercepts is we plug in y equals 0, and then we solve for x. Not for k, for x. So this is the equation. So I'm plugging in 0 for y. 0 equals -2 x plus 2 quantity squared plus 8. I'm going to rewrite this with the 0 on the other side because it's easier. It's just easier for me that way. I want to solve for x, and I'm going to do that by using the square root property. So I'm subtracting 8 on both sides. That gives me -2 times x plus 2 quantity squared equal to -8. I'm going to divide both sides by -2 to get the x plus 2 squared alone. So these -2's are canceling. We get x plus 2 quantity squared is equal to +4. If we use the square root property and take the square root on both sides, if we are to do this, we need to put a plus or minus on the other side, as that is part of the square root property. The square root property, if you don't remember, says that if x squared is equal to c, then x is equal to plus or minus the square root of c. So what it says is if you want to take the square root on both sides like this, because the square root of x squared is x, and that would get rid of the square for you. That if you're going to do that, you have to put a plus or minus on the other side to account for the fact that if you square a negative number, it becomes positive. So that's what that plus or minus does for us. Here, by taking the square root of a square, it's going to cancel that square for us, and we'll have x plus 2 by itself. X plus 2 equals plus or minus 2. That splits this into two separate equations, one with the plus and one with the minus. So it splits into two equations. We have x plus 2 equals +2, and we have x plus 2 equals -2. This gives us x equal to 0 and x equal to -4. Those are our x-intercepts. So here at 0 and at -4. The next bit of information is the y-intercept. The y-intercept is much easier. For the x-intercept, you plug in y equals 0 and solve for x. For the y-intercept, you plug in x equals 0 and solve for y. So the function, let's zoom out here, y equals -2. Instead of x, I'm plugging in 0. 0 plus 2, quantity squared, plus 8. Let's see, that's going to give me 0. So my y-intercept is 0. Now, this makes a lot of sense, right? Because we have our y-intercept already when we plotted the x-intercept 0. If x equals 0 is an x-intercept, the y-intercept must be y equals 0. I'm going to make a note right here. So this is a necessity because this is the point 0, 0. So if x equals 0 is an x-intercept, that's also, by definition, going to be the y-intercept. The domain for all quadratics is going to be -infinity to infinity. This is for all quadratics because it's a polynomial. The range is going to be referring to the y values. So this guy opens down where, okay, let's try this. It opens like this. So the y values that are covered, they go from -infinity all the way up to 8. 8 is the maximum value that this graph achieves. So it starts at -infinity. It goes up to +8. I know it's easy to read it the other way when you're looking at these y values to say, oh, it's 8 to -infinity, but we always do it in the numerical order. So -infinity is a smaller number than 8. If we look at our function, the function is going to have a maximum because it opens down. It has a maximum value of, and when of blank at x equals blank. The way that this works, the maximum minimums of a quadratic only occur at the vertex. So the maximum or minimum value of a quadratic is talking about the y value of the vertex. So the y value at the vertex is 8. So it's a maximum value of 8 at x equals -2. That's the x value of the vertex. And there's that problem. Now, on Alex, if you were graphing something like this, you would also have to graph another 2 points using the axis of symmetry. You could plug in x equals -1, and it should give you 6, and then you could plot another point. I'm not doing it on this problem. This was enough for it. All right. One more problem. A little bit of problem solving here. Find the vertex form of the quadratic with the following properties, then graph the quadratic. So we have a vertex and we have a point that it passes through. So the vertex form of a quadratic, again, is y equals a times x minus h, quantity squared, plus k. So we need to find a, h, and k. Nice thing is that the vertex was given to us, so we do have h, we do have k. So this becomes y equals a times x. Then it's the opposite. So if this is a positive h, we write minus 3 over here. Minus 3 squared plus k. K is negative, so it's actually minus k, minus 2. There's h equals 3. There's k equal to negative 2. We just need to find the a value. Let's plot over 3 down 2. Here's my vertex. Here is my axis of symmetry. We're told that it passes through the point 1, 6. That's right here. So that's going to be enough for us to graph. Telling us that about amount of information will be enough for graphing, because if this point is 2 units away, then I can come over 2 units on the other side, plot another point, and I have enough points. At least if I'm drawing it by hand, I have enough points to graph my parabola. Now, if you were doing this on Alex, you would need to plot other points, but that's not what we're here for at this point. To actually find the a value, though, we're going to need to plug in this point to this equation and solve for a. So I'm going to be plugging in x equals 1, y equals 6 to this guy right here and solving for a. So x is 1, y is 6. Now it's just algebra to solve for a. 6 is equal to a times negative 2 squared minus 2. I'm going to add 2 to both sides. 8 is equal to negative 2 squared is 4. 8 is equal to 4a. Divide by 4 on both sides, and you'll get that 2 is equal to a. So if I come down here and just replace that with a 2, now that's good. So the equation of this quadratic is y equals 2 times x minus 3 squared minus 2. You have enough information to find the entire equation if you have the vertex and another point on the parabola. That's all the information that you need. Something as a last point for this video, although maybe it doesn't belong in this video, but that's where I'm putting it. If you ever want to go back to standard form, because this guy's in vertex form. Standard form, remember, is the form that is ax squared plus bx plus c, whereas vertex form was y equals a times x minus h, quantity squared plus k. That's the one we've been working with. if you ever want to go back to standard form, all you have to do is FOIL this guy out. So 2 times x minus 3 quantity squared minus 2. FOIL out the x minus 3. So you'll have x squared minus 6x plus 9 minus 2. Distribute 2x squared minus 12x plus 18 minus 2. 2x squared minus 12x plus 16. So this parabola in vertex form looks like this, but its standard form looks like this. So sometimes you want to go from vertex form to standard form, and that's how that works. If you want to know how to go from standard form to vertex form, that will be in the next video. All right, if you have questions, let me know. Otherwise, I will see you in the next video. Bye.